Welcome to Next Gen Manufacturing. Today, we are diving into one of the most persistent, most frustrating problems in any machine shop, chatter. We're going to break down how to tame this beast for way smoother, more efficient milling operations. You know that sound, right? That awful, high-pitched squeal or that deep, ugly rumble that just tells you something is very, very wrong. And let me tell you, that's not just noise. It's the sound of a destructive force that is actively wrecking your tool, your workpiece, and yeah, your bottom line. So what is chatter, really? Well, basically, it's this nasty, self-exciting vibration that happens during the cutting process. It is the sworn enemy of precision. It turns a beautiful, smooth operation into a total mess that ruins surface finishes and absolutely demolishes the life of your expensive cutting tools. To beat it, you need a game plan. So here's ours. First, we'll get to know the enemy. Then, we're going to cover the single most important rule for fighting it, maximizing rigidity. After that, we'll load you up with a whole toolkit of practical fixes, including a pretty slick tactic for conquering corners, before we wrap it all up with a big payoff. Okay, first up, let's get a really clear picture of our enemy here. Because before you can solve a problem, you have to understand the damage it's doing. Let's look at the real cost of letting chatter run wild in your shop. And believe me, the consequences are no joke. Chatter leaves behind these ugly, unacceptable surface finishes. It drastically, and I mean drastically, shortens the life of your tools, especially those pricey carbide end mills that are super brittle and hate vibration. All this just adds up to inefficient operations, wasted time, and wasted money. We've got to get this under control. Which brings us to the absolute golden rule of preventing chatter. Seriously, if you only remember one thing from this whole explainer, make it this. Rigidity is everything. And when I say rigidity, I'm not just talking about the tool, I mean the entire system. Think of it like a chain, right? If there's a weakness in any single link, the tool, the holder, the spindle, the machine, your fixture, even the workpiece itself, the whole system fails. And that's exactly when chatter decides to show up. Just look at this comparison. It really says it all. On the left, you've got all the classic mistakes. A long tool overhang just waiting to vibrate like a tuning fork, a kind of loose fixture, and a big gap between the workpiece and the spindle. But on the right, you see the solution. A short, stubby tool, a part that's clamped down like it's never going to move, and everything choked up as close to the spindle as possible. This is the foundation of a chatter-free setup. All right, so we've got our golden rule down pat. Now let's build on it. It's time to fill our toolkit with some real actionable strategies you can start using on your very next job. Strategy number 1 is all about your physical setup. It starts with what we just talked about. Use the shortest tool you can possibly get away with. If the job allows for it, grab a stub-length end mill to really minimize deflection. And hey, take another look at your fixtures. Can you hold that part any more securely? And don't forget the tool holder, A balanced holder is a stable holder. Next up, strategy 2. Let's optimize the tool itself. Choosing an end mill with a bigger, beefier core diameter adds a ton of stability. A small circular margin can also help dampen out those vibrations. And, adding more flutes can lead to a much smoother cut. And always double-check that the tool's geometry, like its helix angle, is a good match for whatever material you're cutting. Strategy 3 moves us from the hardware over to the software. You can actually fight chatter just by reprogramming your toolpath. First, take a look at your part. Where is it the stiffest? Then program your cuts to push the cutting forces into those strong, stable sections. And remember, speeds and feeds are not set in stone. Experiment. Sometimes just a tiny tweak to the spindle speed or the feed rate is all it takes to find that quiet, stable sweet spot. Oh, and here's a fantastic pro tip for you. If you're conventional milling and you start hearing that dreaded chatter, try switching over to climb milling. Just that simple change completely flips the direction of the cutting forces, which can often be enough to quiet the whole cut down and stabilize the operation. It's a really powerful trick to have up your sleeve. Okay, let's talk about a situation that every single machinist dreads: machining into corners. This is where chatter just loves to show up and completely ruin an otherwise perfect part. So why is that, right? Why do corners seem to be a total magnet for vibration? You could be running a perfectly smooth toolpath on a straight line, and the second you hit an inside corner, everything just starts screaming. Well, the reason is actually pretty simple. It all comes down to tool engagement. As that end mill plows into an internal corner, the amount of material it's trying to cut suddenly skyrockets. This huge spike in cutting forces overloads the whole system, and the result is aggressive, damaging chatter. But don't worry, there is an elegant solution. Instead of just ramming into that corner, use this two-step programming trick. First, use circular interpolation to machine a corner that's actually larger than the final radius. This keeps the tool engagement nice and consistent. Then you come back in with a smaller end mill to clean out the little bit of stock that's left, again using circular interpolation to finish it to size. It's an absolute game changer. So after all this, what's the ultimate payoff for mastering these techniques? Well, it's way more than just a quieter shop. When you apply these principles, you are elevating the quality and the efficiency of your entire operation. Let's lock in everything we've learned with a quick checklist. Number 1, maximize rigidity in every single part of your setup. 2, optimize that tool path, paying special attention to those tricky corners. 3, choose the right tool for the job. And finally, number 4, don't ever be afraid to experiment with your speeds and feeds to find that perfect sweet spot. And this is why it all matters so much. The result of mastering these techniques isn't just a quieter machine shop. It is smoother cuts, drastically longer tool life, and consistently perfect parts every single time. It's about moving from fighting the machine to making it truly work for you. At the end of the day, controlling chatter isn't just about getting rid of an annoying sound. It's a fundamental skill that directly defines the quality and the professionalism of your work. So the real question is, are you ready to apply these strategies and take your craft to the next level?